The solution set of a system of inequalities is the set of all points that are solutions of all inequalities in the system. To graph a system of linear inequalities, first, we graph the solutions of each inequality on the same coordinate plane. And second, we indicate the solutions of the system by identifying the region where the shaded regions for all of the individual graphs overlap. An example of such a graph is shown on the slide. In this graph, the points in the red shaded region are solutions of one inequality, and the points in the blue shaded region are solutions of the other inequality. All the points in the darker purple region outlined here are in both shaded regions at the same time, and therefore it's these points that make both inequalities true, and these points that are the solutions of the system of inequalities. Now let's look at an example of this process. We'll graph the solutions of this system of two linear inequalities on the coordinate plane. The first inequality is x plus y is greater than or equal to 1, and we'll graph it in red. The boundary line is x plus y equals 1. This line has an x-intercept of 1, 0, and a y-intercept of 0, 1. So we can plot those 2 points on the coordinate plane. And then since we have a greater than or equal to symbol in our inequality, we'll use a solid line to show that the points on the boundary line are solutions of this inequality. Next, to determine where the other solutions of the inequality are located, we can use a test point. In this case, the origin is an easy point to use. If we substitute 0 for x and 0 for y, we obtain 0 plus 0 is greater than or equal to 1. And this is false. Therefore, the origin is not a solution of this inequality, and it's all the points on the opposite side of the boundary line from the origin that are solutions. And rather than shading them, we could just indicate those points with arrows, reminding us that this upper right-hand region of the coordinate plane contains the solutions of this first inequality. Now let's move to the second inequality. X minus y is less than 5. We will graph it in blue. In this case, the boundary line is x minus y equals 5. Thus, the x-intercept is 5, 0, and the y-intercept is 0, negative 5. We can plot those 2 points on the coordinate plane. And then notice that we have a less than symbol. This means that points on the boundary line are not solutions, and so we'll use a dashed line for this inequality. Once again, we can use a test point to determine on which side of the boundary line the solutions fall. The origin, if we substitute, would give us 0 minus 0 is less than 5. This is a true statement, so the origin is a solution, as are all the other points on the same side of this boundary line as the origin. We can indicate that with these arrows pointing toward the upper left portion of the coordinate plane. Now to identify the solutions of this system of two inequalities, we notice that the area where the shadings, the red and blue shadings, would overlap is this sort of upper region of the coordinate plane. All the points in this area would make both inequalities true, and therefore these are the solutions to the system of inequalities.